ratio, just the 10 rib belt is used, and on the high speed ratio, which is a very large diameter drive pulley, 5 ribs will transmit all the power. When we visit the factory, all these components will be examined in much greater detail. The control box is on a 24 volt spur. It features an on-off switch which operates simply by twisting or depressing. The acceleration and braking ramps are controlled on this switch, so you have fast or slow acceleration. Forward or reverse rotation, because of the bayonet fixing, that's very useful and very safe. The actual speed control itself is operated on this dial, and according to which range you've selected, which pulley ratio, then you simply read the speed off one of these 3 scales according to the diameter of the pulleys that you've selected. The actual speeds are also marked on the window here, so that on the low speed we have 50 to 500, on the intermediate speed 150 RPM to 1350, and on the high speed ratio 250 to 2600 RPM. The reason why these 3 ratios are necessary is that every electric motor has a power delivery curve which is at its optimum within certain revolutions. So it's not possible simply to run the same motor from 0 up to its maximum speed and obtain an even power or even optimum power. So the 3 ratios enable you to use the motor to its full potential. All the covers and hatches on the machine are micro-switched so that when they're opened, the lathe automatically stops. Here we have a hand wheel. The access to the thrust washer assembly is also here. There's an indexing facility. There are 48 positions in which the shaft can be locked for radial drilling, decoration and so on. The cover can't be closed again with the shaft locked, but has to be taken out before the machine can start again. Another useful feature is that provisions made for fitting angle poise lamps wherever you might find them convenient for seeing inside the work. In fact, you can use 1 or 2 lamps. Provisions for mounting the lamp on top here or in the side. Of course, the tailstock isn't strictly necessary for bowl turning. Most bowls can be turned without a tailstock, but there's no doubt that it is useful. It can add a lot to the creative potential. For example, if you have a large piece of wood, a blank with particular features in it that you want to preserve, you can bring the tail center up to retain a certain feature or to eliminate a feature. You can find the centers of balance or the best turning center for the piece. Also in long hollow work, vases and so on, having a tailstock is very useful to give support in the initial roughing down stages. Now here we have a capacity of 27 inches diameter by up to 30 inches in length, so that's a huge piece of wood. The problem with most conventional tailstocks fitted to a bowl turning lathe is that when they're not in use, they tend to impede the stance of the wood turner because they're located directly under the centers. Here you'll notice that the bed is offset by a considerable amount so that the turner can still stand directly in front of the workpiece without interference from the bed. So when required, the tailstock is simply slid along the bed to whatever position necessary, clamped, do the work, and then when not required, it simply pivots over and can be parked wherever it's out of the way. Now the turner can stand squarely in front of the work and manipulate the tools for bowl turning or whatever shaping operation is required without interference from the bed. You'll see a projection here which butts up against the lower bar. I'll explain how this is adjusted to align the tail centre in a moment, but the advantage it has for this purpose is that no matter how the tailstock is positioned or parked, when it's brought back into use, it automatically locates to give a perfect centre alignment. So with the tailstock set and the work mounted between centres, the tool rest can be positioned and the turret lever taken out, that just pops out, so that the tool can be fed right into the turning axis without any obstruction from the tailstock body. The turret lever has a machined pinion on its end that engages in a rack on the tailstock quill. 4.5 turns provides 150 millimeters of travel, just about 6 inches in fact. So it's very fast to operate and extremely powerful if you're drilling with big Forstner bits or sawtooth bits. The quill is also bored through so that a long hole boring auger for lamp stems can be fed through. We supply a specially elongated auger to allow for this length, plus the 30 inches projection of the auger itself. If the drilling depth needs to be precisely controlled, you'll see that there's a scale set into the quill so that the depth can be measured accurately. The fittings are number 3 Morse taper. We also supply reducing sleeves so that 1 or 2 Morse taper fittings can be used. We've designed the VB36 so that the tailstock assembly can be fitted at any time and aligned by the user. Strangely, alignment on centre turning lathe, that's spindles, isn't a critical factor. The centres can be way out of line, it doesn't really make any difference. On a bowl-turning lathe, where the work will mainly be mounted on the headstock by means of a chuck or faceplate, centre alignment is critical. It's important that the tail centre, when it's brought up to the rotating work, is on a precise geometric centre of the workpiece. I'll show you how this works in practice, the alignment feature. I'll bring the centres together. Now the top bar is in effect a giant rotating cam, and with the clamps at either end of the bar slackened, we use an adjusting bar to actually rotate the bar, the top mounting bar, and that has the effect of raising or lowering the entire tailstock body assembly. The lower bar also is on a similar system, so that when that is rotated, that has the effect of moving the centres from side to side. So you can get precise crosshair alignment of the centres, which can be maintained throughout the life of the machine. Of course, every manufacturer makes claims for their machines, which would lead us to believe that almost any lathe can turn 30-inch diameters. What we really want to know is, what will they do? So we're going to look at the work of several turners and show you exactly what the VB is capable of, from the very largest pieces weighing some 600 weight down to very, very small pieces indeed. The beauty of the machine is that it turns with absolute precision, irrespective of the size, weight of the work.
The VB is the best lathe in my workshop. I chose VB because of the size, the weight and the bearing configuration. And after I got one, I soon had to get two. Because teaching, as I do, some advanced techniques, I need lathes that are reliably steady and smooth. This is the biggest thing I've ever turned, this 5-foot 6-inch teak bath. And the smoothness and silence with which it goes around has impressed me even more. I've done things on VBs from this big up to this big, and I've never been disappointed with the bearing system, with the shaft size, which is basically what a lathe is all about. It doesn't matter so much what the casting looks like, it's the shaft size that gives you the smoothness of hold on your spinning workpiece. After that comes the casting, and the heaviness and solidity of the VB has also done everything that I've asked of it. I've got smaller lathes, and for spindle work I use graduates, but if there's anything at all demanding, I come back to the VB, and I've never been disappointed.
It's a machine with immense strength. It's got a big heart, but it runs smooth as silk, and you can hear what you're doing, whereas so many other machines have a noise going on to irritate your ears in the background. You can hear precisely what the tool's doing. I find that really beneficial. It's got tremendous access all around the machine for working, whether you're close up to it or outboard on the tailstock end. It's just very strong and solid, and it's not enormously oversized, so if you've got to fit it into a small workshop as we have here, then it does enormous jobs in a very small space, which is very beneficial.
I've been using a VB36 since it first went into production in 1996. This is the very first lathe that I acquired, number 16. Since then, I have 2 more lathes in my school. So my students and myself get to use these lathes pretty much all the time. This gives me great pleasure. And I say this coming from someone who has built and designed 4 of his own lathes. And I thought they were pretty good until I got my hands on one of these beauties. Reasons why I particularly like the lathe. Well, when I'm turning my big vessels and bowls, such as the one you see here, I have the solidity of a big heavy cast iron headstock. I have bearings in there that are totally reliable. There is no rumble or noise because there are no balls or rollers. It's a plain bearing, no end float, no lateral movement. It's just brilliant for doing really heavy work. Well, of course, having talked about bigger pieces, this is my favourite work, turning sea-flower multiple rim pieces, and the lathe really comes into its own here with the bearings that I've just waxed lyrical about. No noise and completely vibration free. It allows me to do this delicate work, working in between the rims. You can see how thin they are, and then hollowing out to the same wall thickness of the rims. Being delicate work, I need to concentrate. One false move and I break the piece. This lathe really does allow me to do that work in comfort and peace. I'm really excited about this new bit of kit here. VB have produced a bed that will slide in and out. You can move it out of the way and yet put it into place by the operation of a couple of levers, and we can work between centres, reorientating a piece until we get the correct balance, or indeed for multi-axis pieces where we can change the axis as we're turning and produce some pretty interesting sculptural work.